In this video, we're going to factor a polynomial function and then sketch it using its zeros. So the first thing we are going to do is factoring. Now, looking at the function fx, it's obvious that we can factor x out. So f of x is equal to x, and then inside negative x3 minus 5x2 minus 3x plus 9. Okay, good. So now what we need to do is to factor this polynomial here. Now we have no information about this polynomial, so it might be a good idea to use the rational zeros theorem. So rational zeros theorem, we are going to explain it and then use it at the same time. So we are going to use the rational zeros theorem to polynomial Rx. Good. Now first you look for the constant term of Rx. Let's call it Q equal 9 here. And then you look for the leading coefficient of the same polynomial. Let's call it P, and it's equal to -1. This is 9. Good. The second thing you do is you look at all the factors of Q and P. So this is the constant term. This is the leading coefficient. Now what are the factors of 9? Plus or minus 1, plus or minus 3, plus or minus 9. You also look at all the factors of P equal -1, and these are plus or minus 1. Now if Rx has a real zero, it will be given by the ratio of the factors of Q over the factors of P. Good. So let's start with the Q equal plus or minus 1. So plus or minus 1, and then P divided by P, which is plus or minus 1. This will give you either 1 as a 0 or minus 1, -1. Okay, good. Now let's go for the next value, plus or minus 3. Q for Q. P, it's still plus or minus 1. There is only these two values, and that will give you either 3 or -3. Next, plus or minus 9, plus or minus 9, and then we divide it by P, which is plus or minus 1, and this also give you 9 or -9. So these are the possible zeros of our polynomial. Now that we found the possible zeros, the only way to find any zeros is to test them. So we're going to start testing the first one, x equal to 1. Now to test if it's a 0, we calculate R of 1. So R of 1, substitute x by 1 here. So minus 1 power 3 minus 5, 1 power 2 minus 3, 1 plus 9, simplify, minus 1 minus 5 minus 3 plus 9. Now a quick calculation gives you this equal to 0. Now, since R of 1 equal to 0, that means x minus 1 is a factor of Rx. Yeah, this is your 0, and it goes like this: x minus the 0, x minus 1 is a factor of Rx, and therefore now we're going to say that Rx is x minus 1 factor multiplied by certain polynomial Qx. How do you find this? Very simple. Qx is equal to Rx divided by x minus 1. Yeah, you just divide this side and this side by x minus 1, you simplify, and then it will give you Rx. Now, This is a linear factor. X minus 1 is a linear factor, so we're going to use the synthetic division of polynomials. Now we do this as follows. Now we compare this to x minus k. So when you compare this with this k equal to 1, you put the k here, 1. Here you put the coefficient in the polynomial Rx, which are -1, -5, -3, and 9. So -1, -5, -3, and 9. And then we start synthetic division. This is brought here. And then this is multiplied by 1. This one here, the k. That gives you -1. You add now the -5. You add the -5 with the -1. That gives you -6. You multiply the -6 by the k, which is 1. So you multiply by 1, -6. You add these two, gives you -9. You multiply -9 by 1, again the same one here, and that gives you -9. When you add it, gives you 0. This is the remainder 0. We would expect 0, of course, because x minus 1 is a factor. And now we write our polynomial Rx as follows. Rx equal x minus 1 multiplied by Qx. Qx is here, the result of the division. So we put it here. Now we know it's degree 2 because we divided degree 3 Rx by degree 1. We are left with degree 2. So minus x2 minus 6x minus 9. Good. We continue. Now it looks like it would be a good idea to take this minus here and here and here and factor it out here. Now you can see much better like this. And this looks like x plus 3 power 2. So we end up with the complete factoring of the given function. No, hang on. Let's finish with Rx first. So this is x plus 3 power 2. This here. Now when we go back to our function, the given one, it will be fx equal minus x minus 1, x plus 3 power 2. This is how we factor fx completely. We now go to part B, which is sketching. We are going to sketch the graph of f. The first thing is to determine all the zeros and their multiplicity. The first one is 0, x equal to 0. The multiplicity is the power that comes. Now when we say x, it's like x to the power 1. So we say multiplicity 1. At multiplicity 1 or 3 or 5, at odd multiplicity, the graph will cut the x-axis. The next 0 is x equal to 1. Again, this is power 1. So multiplicity 1. The graph also will cut the x-axis at x equal to 1. The third zero is x equal to -3. This has multiplicity 2 here because of the power 2. Now multiplicity 2, 4, 6, even numbers, the graph will not cut, it will touch the x-axis. So cut, cut, touch. This will help in graphing. Now remember the main term, the leading term in our polynomial is -x4. As you increase the x's in absolute value, this term will dominate. All the others are smaller. So we're going to think in terms of -x4. Now, if x goes to plus infinity, so if x goes in this direction, now let's bring this down here. That means if x take positive values like 1000, 1 million, and so on, x to the power 4 will be positive, and then there is a negative sign here. So the y value will go negative. Will go negative, smaller values, but with large absolute value. Good. Now, if x approaches negative infinity, meaning that it takes values that are large in absolute value, but negative. Like, for example, minus 1000. Now take minus 1000, power 4, it becomes positive, and then with the minus here, it becomes a very small negative number, meaning a very large absolute value and negative. Again, the graph on this side will go down because this is negative infinity for the plus, for the x, and this is the plus infinity. So here on the left and on the right, our graph will go down. Now let's go back to the zeros. Let's start with 0 and 1. The 0 and the 1 are somewhere here. This is x equal to 0, and this is x equal to 1. Now, this the graph on this side goes down. So this is a 0. The only way is for the graph from the 0 to go down like this. Between the 0 and the 1, there must be a maximum, because the graph cuts the x-axis. Hang on, let's do this a little bit better than this. So let's put a point here and then go down. This is a little bit better. Good. Now there is 0 at x equal minus 3. Minus 3 is somewhere here. At minus 3, the graph will touch. When we say it touches, it behaves like a parabola touching the x-axis. Because remember, it's x plus 3 power 2. This is a parabola. So does it go up or down? It has to go down because this side will go down. Remember this? And then the only possibility now is for the graph to go like this and then up to the 0. So this is a very, very rough sketch. Normally, we should take more points and find values and points on the graph and so on. But this is the main idea of sketching. You find the zeros, the multiplicities, the behavior on left and right, and then you put all this together. Now, we have reviewed quite a few things in this video. The rational zeros theorem, the zeros, division, synthetic division of polynomials, and how do you use division to factor, and then the zeros, their multiplicity, their behavior at the x-axis, and then sketching. So these are quite few things in polynomials to master.